Basically, in this problem, I'm on page 208, or I think it's really 210, number 77, and we have to represent the area of this figure. But first of all, since we have two variables, we need to use the information we know to set up and solve one variable for the other. So basically, in this problem, there's 200 feet of fencing that's going to fence this area. So if I look at this, this is x and this is x, so that means I got x here, I've got x here, but I have y here. So the 200 feet of fencing is really 4x plus 3y equals 200. Now, I really need to determine area, and remember area is length times width, right? And so what's the length and what's the width? The length is 2x times y, right? But if I want to do this in terms of x, I need to solve for y. So how do I solve for the y that I need here? I had to use the information about the amount of fencing that was being used. Now, this is kind of a no-brainer. Solve for y. So how about this? 3y equals 200 minus 4x. Now I can divide by 3. Divide by 3. I'm going to write it so that it looks like this. 1/3 200 minus 4x. Now, hopefully, you see the similarity between this equation and what they gave you in the problem. Now, they wanted you to continue the problem for, I think, 6 steps. So if 2 is here and 4 is here, hopefully you could use some logic and know to use 6. You know what to use next, 8, and so on. And you can fill in the chart. Notice here, it's 1/3. I've got the 200, and then 4 times x. And in this case, the x was 2. In the next case, I'm going to have the x as 4, and then 6, and then 8. Now, again, when you type it into your graphing calculator to take a look at it, you're going to type in this equation here. And be careful of the parentheses and make sure you do the fraction right. And don't use 0.3, use the fraction 1/3 so you get the most exact answer for maximizing. I think this is probably enough to help you finish the problem on your own, so good luck.